Hello, Algebra 2. Here we are with our 8B Summative Review Worksheet. Alright, remember the first page of your test will be no calculator. No calculator. Alright, so as I'm looking at this, we have x minus 4 in the denominator. So I'm looking at, we cannot have x equal 4. So x is not going to be 4. I cannot have x equal 4. Okay, because of that, we will have a vertical asymptote at x equals 4. And we need to have that labeled or announced somewhere on there. 1, 2, 3, 4. Okay. There's our vertical asymptote at 4. Then looking at our fraction, there's a higher power of x on the bottom than there is on the top. So that should pull down our horizontal asymptote to 0. The bottom of our fraction would be growing. The top isn't. So the bottom's going to get bigger and bigger. We're going to be dividing by bigger and bigger things, which would pull us down to 0. But then we have this plus 2 on the back, which will bump everything up 2 units. So 0 plus 2 is going to bump this up to a horizontal asymptote of 2. And again, y equals 2 somewhere on there. Let me know that you know it's a horizontal asymptote. Okay, for the first page, the no calculator page, you do not have to have a dot on there, but you do have to have the curves, okay, somewhere in there. Now, I would definitely recommend doing a dot mentally or with your scientific calculator, just to be safe, because I know we're so used to having them be there and there. Okay, but a negative is going to flip the script, and we're going to be here and here. Okay, so if our vertical asymptote's at 4, I'm going to pick 5, 1 unit to the right. 5 minus 4 is 1. Negative 3 divided by 1 is negative 3. Negative 3 plus 2 is negative 1. So we're at 5, negative 1. And now I see, oh, my dot's over here. We're in the bottom right. We're going to follow our asymptotes for our curve. Okay, that might be all you need. And then the top one, just go like that. Or we've already come this far, we might as well do another dot. 1, 2, 3. 3 minus 4 is negative 1. Negative 3 divided by negative 1 is positive 3. Plus 2 is 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, there's our sketch. Domain, x is not equal to 4, and range, all y's not equal to 2. Alright, and now you're at a 1. Now you're at a 1. Okay, important things. Vertical asymptote. Okay, looking for our horizontal asymptote, especially if there's a plus or a minus on the back. Making sure we have those labeled. Okay, you do not have to do a dot, but we do have to have the little swoopies in the right spots. Okay? Onward to the next type of problem. Okay, second type of problem. Points of discontinuity, holes in the graph. If you see all these factored things, that should be a hint that we need to factor. Okay, the denominator should factor out to x minus 4 and x minus 1. Okay, and then so I'm thinking x cannot be 4 and x cannot equal 1. And now I'm thinking vertical asymptotes. But then I see that this x minus 1 cancels out. And that's got me thinking cancel. And now I'm looking at x squared minus 16 a little closer. And oh, x squared and 16, those are perfect squares. We have a difference of perfect squares. So x minus 4, x plus 4 for factoring those. And our x minus 4's cancel. And all we have left is x plus 4. So now instead of asymptotes, we're going to have holes in the graph. We're going to graph it like y equals x plus 4, but we have holes at 4 comma blank, 1 comma blank. Okay, instead of having asymptotes, when they cancel out, then they turn into just holes in the graph, empty dots. Okay, 4 comma what? Well, if I put 4 back in the original, I'm going to get an error because I can't divide by 0. But if I put 4 in the reduced one, we get 4 plus 4 for 4 comma 8. And then if I put 1 in here, 1 plus 4 is 5. So those are holes, empty circles. 1 comma 1, 2, 3, 4, 5. And 4 comma 8. 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Graph it like y equals x plus 4. So we're going to start at 4 on the y-axis here. And 1x. So our slope is up 1 over 1. Don't fill in the empty circle. Dot, dot, empty circle, dot. I'm going to go backwards until I hit the x-axis, because I already saw this over here. The first question is x-intercept. So I'm just going to keep going backwards until I hit the x-axis, because I know the first question is about x-intercept. Okay? These holes are more formally known as points of discontinuity. Discontinuity, not continuous. Okay, so we have to pick your pen or pencil up to draw your line, because you have to stop, pick it up, move it, start again. So there's our graph. Now let's answer their questions. X-intercept, we cross the x-axis at -4 comma 0. Y-intercept, we cross it at 0 comma 4. Max and mins, we don't have that for these. This is not a max and min graph, this is a holes graph, points of discontinuity. So we're going to be at 4 comma 8 and 1 comma 5. And domain and range, usually a line is all real numbers for everything, but because of the holes, we're going to be missing 2 x numbers and 2 y numbers. We're going to have all real numbers x except 1 and 4 from your points of discontinuity, and range all y's that are not 5 and 8. And now we're up to a 2.5 because we have 2 graphs correct for the 2, and we have 2 out of the 3 domain and ranges. So that'll give you enough to be a 0.5. Last one, third type. Okay, this is going to be our split range graph. Okay, let's look at what we have here. 2 over x squared plus 2x minus 3. So we can factor out the denominator to x plus 3 and x minus 1. Nothing to cancel those out with. So we don't want -3 and we don't want 1. Don't want, not equal to, Mr. Handke. Okay, because we don't want those are going to cause problems. We will have vertical asymptotes, VAs, at x equals -3 and x equals 1. Okay, I'd like you to say something about that either here or like on the edge of the graph next to your vertical asymptote lines. So we got a vertical line at 1. And if you've already said something about it over here, that's fine. If you haven't, we definitely should put it here. And -3. 1, 2, 3. Okay, horizontal asymptote. The denominator has a bigger power of x than the numerator. The numerator doesn't even have one. Denominator has a bigger power of x. So the denominator is going to grow much faster than the numerator. So the denominator is going to get very big very quickly. very big to the positive side and also very big to the negative side. So it's going to be dividing by very big numbers, and it's going to pull this down to 0. Okay, and we don't have a plus or a minus on the back to bump it up or down. So our horizontal asymptote will be at 0. Alright, and now is finally the part where maybe you would need a graphing calculator. Okay? So we're going to type it into y equals, we can either use your fraction bar, or we can go 2 divided by parentheses. Okay? Graph. There it is. If yours is skewed off center or not looking like that, I would go zoom 6. Zoom standard, zoom 6 fixes a lot of issues. Okay? Now this graph, we do need to have a dot, one dot on every part. At least one. If you want to go more than one, feel free. Okay? So our vertical asymptote there was at -3. Let's go -4. Trace, -4, enter, and we get -4, 0.4. Not a perfect point, so we're going to label it. Okay, and then we'll sketch our curve there. Very sharp turn. Okay, the other easy one is over here. Again, if our asymptote was 2 or 1, we're going to go 1 outside of it to 2. Trace 2, enter. And we get 2, 0.4. 2, 0.4. Alright, excuse me. Now, the one in the middle, it's kind of a parabola-looking shape, so we're thinking we need the vertex. That's going to be the most important point. The vertex happens at the very, very top, or if it was the other way around, very, very bottom. So we need to do second, trace, maximum. Alright, it always starts with the left bound. Your calculator will always start it with the left boundary. So you need to hit left until we get to the left-hand side of the middle. Okay, there's the middle. Just get clearly to the left of it. You don't have to go this far over. Like you could be there and it'd be fine. Okay, left side, enter, and then it changes to right side. You're setting 2 boundary lines, and then your calculator is going to find the maximum or highest point between those 2 lines. And guess in the middle. -1.000001, comma, -0.5. It's -1, -0.5. Okay, and then we follow our asymptote, our outside asymptote lines down and out. Okay, when you have 3 pieces, the outside pieces have to follow this horizontal asymptote. The middle stuff doesn't always have to. It gets a little weird sometimes, and that's what we have going on here. These 2 come down and get infinitely close to 0 as they go to the outside. The one in the middle looks like it's going to go up to 0, but it stops at -0.5 and turns around, which you might think is, oh, that's close enough to 0, Mr. Handke. That's actually a lot to be away from 0. -0.5, between -0.5 and 0, you could come up with an infinite amount of itty-bitty little decimal places of numbers that you're not going to use. Okay, we'll talk about that over here in a second. Okay, x-intercept, we did have x-intercept, we have a horizontal asymptote at y equals 0, so we won't cross the x-axis there, so none. Y-intercept, we do cross it right over here. I don't have that dot yet, so let's use our calculator. Y-intercept is always going to be 0, comma. So trace, 0, enter. -0.6 repeating. You do need the repeating. Or let's go 0, negative 2/3. Okay, fraction or repeating bar on that decimal. Maximum, we have that, -1, negative 0.5. We did not have any minimums or low points. No points of discontinuity. Domain, all x's not equal to -3 and 1. Now for the range, okay? We talked about how the outside two are coming down and getting infinitely close to 0 and not touching it. But the bottom one doesn't do the same thing. It stops at -0.5 and turns around. So there's that little gap there that's technically an infinite amount of numbers that we wouldn't use for the range. So this is called a split range because you need two pieces. You're splitting it up. The top, y is greater than 0, and the bottom, we're less than or equal to -0.5, because we do use that point. We do touch -0.5 right there. Okay, and I will be very picky on those inequality symbols. Okay, make sure we're using the right ones. Alright, that should take care of it for everybody. Hope that was helpful. Study up, and good luck.